Video is going to be about factors. A factor is a number that is multiplied by another number to get a product. So that's the first set of notes we're going to write down. Anytime you've done a multiplication problem, like 4 times 12 equals 48, you have had two factors. This is a factor and this is a factor, and both of these are factors of the number 48. We're also going to look at something called factor pairs. Factor pairs are two whole numbers that are multiplied together to get the product. So whereas a factor was the individual number, factor pairs are pairs of numbers that equal a product. The reason we're going to need to know about factor pairs is because we're going to be doing some things called divisibility rules. Divisibility rules are rules that will help us when we get into fractions and doing things with fractions, like equivalent fractions and adding and subtracting fractions and other tasks that we use with fractions. Now you made a foldable that has 8 tabs. We're going to learn 7 divisibility rules. So on the very first tab, I just want you to title it Divisibility Rules. For each page, I'm going to give you information to put on the front of the tab and then when we open up the tab. So the very first tab on the front, when it's closed, should be divisibility rules. So if you have your little foldable that we made, when it's closed, you had where the tabs that we cut, and there were 8 tabs. Right now, this right here, divisibility rule, should be written in this space right here. So I'm going to go through on a different page for each one, and on the cover of all this, before we open it up, we're going to write different items. So divisibility rules is on the first. On the second, we're going to put divisible by 2. On the third tab, we're going to put divisible by 3. On the fourth tab, divisible by 4. The next tab, divisible by 5. On the next one, we're going to put divisible by 6. The next tab, divisible by 9. And on the very last tab, which is the 8th tab, divisible by 10. So first tab all the way down to 8th tab should have something on the front. Now we're going to go and open it up, and we're going to be writing on the inside. So now when you open up this divisibility rule, you actually have the little tab open, and we're going to write in this space here. Okay? I'm going to go ahead and erase this so I have some room. Inside the tab for divisibility rules, we're going to write what it means to be divisible. A whole number is what we're talking about. So when a whole number is divisible by another number, that means that the quotient is a whole number and the remainder is 0. So that means if I divide a number into another number and I get no remainders, then it was divisible by whatever I divided by. So this is the information that should be on the inside tab. The word divisible, like we said, was a whole number. So an example here, if I was dividing 16 by 4, I know that 4 goes into 16 4 whole times, and there's nothing left over. So 16 is divisible by 4. But if I turn it around and I put 4 into 17, I know it goes 4 times, but there's going to be a remainder of 1. So 17 is not divisible by 4. So we're going to be using these rules to help us find out if a number is divisible by another, so we can get factor pairs, which are going to in turn help us with fractions later on. On your divisible by 2 tab, go ahead and open it up now, and you're going to write the inside if the number is even. So the rule for any number, any whole number, it can be divisible by 2 if the number's even. If it's not even, it will never be divisible by 2 because there would be a remainder. So any number ending in 0, 2, 4, 6, or 8 is divisible by 2. So an example, 284. That very last number is one of the even digits, so it is divisible by 2. A non-example, 285. That ends in a 5. It's not one of the even digits, so it is not divisible by 2. It's as simple as looking at the last digit. If it's an even digit, it's divisible by 2. One of the easiest of the divisibility rules. Go ahead and open up, and here's the rule for divisible by 3. This is an interesting one. This is on the inside of the tab. A number is divisible by 3 if the sum of the digits of the number is divisible by 3. And you're thinking, what in the world does this rule mean? So let me show you an example. If I had the number 282, I'm going to get the sum of this number. I'm going to add each digit together. So 2 plus 8 is 10, plus 2 more is 12. I know that 3 goes into 12 4 times with no remainder, so 282 would be divisible by 3 when I go through the process. A non-example, let's say we had 284. 2 plus 8 plus 4 would be 14. 3 does not go into 14 an even amount of times. There is a remainder, so that is not divisible by 3. So it's just a matter of adding up the digits. Open up your divisible by 4 tab. Here is the rule. If the last 2 digits are divisible by 4, if the last 2 digits are divisible by 4, then we know the whole number is divisible by 4. So let's do an example, and we'll do a non-example, just like we've been doing. We can do 384. Last 2 digits, it doesn't matter about anything in front of the last 2 digits. If I know 4 will go into that evenly, then it's divisible by 4. Well, 4 goes into 8 2 times, 4 goes into 4 1 time, so it would actually go into that 41 times, so that's an even amount of times, so it is divisible by 4. And let's try a non-example now. Let's say we had 221. Only looking at the last 2 digits, I know that 4 times 5 is 20, so 4 is not going to go into 21 evenly, so this is not divisible by 4. I don't even have to go through the whole process. There would be a remainder on that one. Your next rule, divisible by 5, is one of your easiest rules, just like the 2's. A number is divisible by 5 if the last digit is 0 or 5. So you're writing this on the inside tab. Do an example and a non-example. Our example, 285. Last digit is indeed a 5. It's divisible by 5. I know that 5 will go into that evenly, the whole entire number. Non-example, 283. Last digit is not a 0 or a 5, so it is not divisible by 5. Divisible by 6 rule. The only time a number is divisible by 6 is if 2 and 3 both go into the number as well. So for 6 to work, the rule for 2 and the rule for 3 had to already work. If it works for 2 and then not 3, I know 6 is automatically out of the question. So let's say, here's our example, 84. Okay? My divisibility rule for 2 says if it's an even number last digit, it's going to work. So 2 works. Then 3, I had to add up my 2 digits. 8 plus 4 is 12. I know that 3 goes into 12 evenly, so 3 does work indeed. So that means that 6 is going to go into 84 an even amount of times, and it actually goes in there 14 times. Because 6 goes into 8 one time, there's 2 left over, which is 24, and it goes in there 4 more times. So that number would be divisible by 6. A non-example, say we're doing 45. Look at the last one. It's not even, so 2 doesn't work. We'll go ahead and check out 3. We have to add the 2 digits. 4 plus 5 is 9. Well, 3 does go into 9 evenly, but because 2 didn't work, 6 is automatically out. Both of them have to work. The divisible by 9 is very similar to the divisibility rule for 3. If the sum of the digits is divisible by 9, then it is divisible by 9 for the whole entire number. Let's look at an example and a non-example, very similar to the 3 rule. Okay, first thing we're going to do is we're going to add up the digits. 1 plus 8 plus 9. 1 plus 8 is 9. 9 plus 9 is 18. I know that 9 goes into 18 an even amount of times, so this number right here is divisible by 9. A non-example, add the digits together. 2 plus 7 plus 5. 9 plus 4 is 14. I know that 9 is not going to go into 14 an even amount of time, so this is not divisible by 9. The divisibility rule for 10. If the last digit's a 0, it is divisible by 10. So an example could be a huge number, doesn't matter. If that very last digit's a 0, this is divisible by 10. It does not matter. Here's a non-example. If that last digit is not a 0, it is not divisible by 10. These are your divisibility rules, and while you may be feeling a little overwhelmed, we'll be using them a lot because they're not just good with division problems, but they're also going to be very valuable to us when we start working with fractions a lot more.